Now we're going to talk about relative extremum. So what this is, well, we're going to talk about extremum, and we're going to talk about the difference between relative and maximum, and we're going to talk about how to find a maximum extremum, not a maximum, a relative extremum. So a relative max and a relative min, and an increasing interval and a decreasing interval. And we as mathematicians usually say increasing, decreasing, relative max, relative min, all in one word, all in one breath. It's all the same thing because you find them all the same way. So the definition of extremum is that it's where you have, so if you have a function that goes up and down, so right here, this value right here is a max, and this value right here is a min. Now, they're not absolute max or mins because the function goes on and on and on forever in both directions. If I had a parabola or something, this would be considered an absolute max because it's the maximum value for all the function. All right. A relative max is within what we in math call a neighborhood. So it's within a region around that point. And yes, you could say, well, if I make that region be from here to here, then it's no longer a relative max. Yes, but you typically make that region be kind of close to the point. All right. So now let's go on. The critical point, which the critical number are all the possible points for the relative extremum. Okay, so these are all possible points for relative extremum, and that is where the derivative equals 0. So the critical points are where the derivative equals 0. So these occur where f prime of x equals 0. Those are the critical numbers. Okay, and these are the possible relative extremum, are the values of c. So you're going to set the derivative equal to 0 and solve for x, and those x values will tell you c, your critical numbers. Now, if x, now I'm going to go right down here and I'm going to give you a little bit more information, okay, here. So, if x is increasing, so then am I in the right place? Yes. All right. So if x is increasing, what that means is the derivative is going up. Okay, actually I think where I want to be is here. This is where I want to be. And I'm going to use the actual bottom of the page to do this. So what we're going to do is we're going to make sign charts. And so you're going to have 4 different possible sign charts. So you're going to have sign charts. And these are similar to the sign charts we did for inequalities, and we're going to review those in just a minute. So for part A, it's a negative. For part B, okay, that's first derivative test. So what I'm going to do is I'm going to show you increasing, decreasing. I'm going to show you relative max, relative min, and then I'm going to show you saddle points. All right. So this kind of is putting together 6 and 7. So I'm combining 6 and 7, and I'm showing you down here how to do 6 and 7. So you have a relative max, all right, and your sign chart for relative max will be your critical point, And I want you to draw all your sign charts the same way I'm drawing them here. And that is what a relative max sign chart will look like. A relative min sign chart would look like this. Negative, then positive. So it's going to go down and then up. Okay? And then you're going to have two kinds of saddle points. And a saddle point is a point that is neither a relative max nor a relative min. So you can have a saddle point that is negative, negative, or a saddle point that is positive, positive. And these are neither max nor min. Okay, and those are your two saddle points. And for all of these, I'm going to put a little f prime here because you're only using the first derivative. Okay, so now let's go on and let's work. Now, for the first couple examples, I'm not going to actually calculate these. I'm just going to kind of review a little bit so that you can see what we're doing. So you can kind of wrap your brain around and get caught up on. So here, we're going to read the graph. We're going to find where it's increasing and decreasing, and the relative max and min. And we're just going to read it off the graph. Okay? So, I'm increasing from, so if I put my pin here, I'm increasing from negative infinity to negative 8. And then I'm decreasing from negative 8 to negative 4. Then I'm increasing from negative 4 to 0. And then I'm decreasing from 0 to 3. And then I'm increasing from, I'm out of room, so I'm going to just put a little arrow, from 3 to infinity. So I have a relative max at negative 8, 15, and one at 0, 14, and I have a relative min at negative 4, negative 13, and at 3, 10. Now, there are two things I want you to know. These two are points. These two are intervals. And they all look like points. All right? Okay, now let's go back up here. Now let's go down here. And let's talk about how to solve this inequality. The first thing we do is we factor. So that's x minus 2 times x minus 1 is less than or equal to 0. So x equals 2 or 1. Then I draw a sign chart. I have 1 and 2. And then I pick values in each of the regions. So 0, 1.5, and 3. And then I test my values. Now remember that I only care about the sign. So for 0, I'm going to put it back into the original. And so I get positive. For 1.5, I'm going to put it into the factored version. And so I get negative times a positive. So I get negative. And for 3, I'm putting it into the factored. And so I get a positive times a positive. So I get positive. So here, sorry, I don't care about, this is not what I'm getting from this in here. I'm looking for positive and negative. And I am positive and negative infinity to 1, union 2 to infinity. And I am negative in 1 to 2. And remember that when I'm doing my sign chart, that I only care about the signs. Okay? So that's how to do a sign chart. Now I'm going to put down here that here